My name is Danaswara Prawira, and I would like to presenting about enhancing security method in software-defined network with deep packet inspection. Okay, first thing first, what is the problem that we have? First is lack of security. Why? Because in the SDN network architecture, there is open-flow protocol that managing all the network. When it large network, SDN will be lack of security. And second is performance decrease. The performance decrease when it comes attacker to the SDN network, and then the performance like delay and bandwidth will go decrease. Okay, software-defined network. What is software-defined network? Software-defined network is first architecture network that separate control and data plane. The control plane in here is managing network, such as the way from the sender to the receiver, and then the data plane is for collecting the information from the sender to the receiver. Okay, and then the open-flow protocol is the default protocol that SDN have. The open-flow protocol is managing the control plane and data plane, and then the centralized. In here, software-defined network, we're centralizing the network. And then the packet inspection. The packet inspection provides scanning several layers of OSI or open system interconnections. There is application, presentation, session, transport, network, data link, and then physical. The packet inspection that I use is NDPI, which is using a holographic algorithm or pattern matching. And then the third is prevention and insertion security. The packet inspection will prevention the messaging and then doing blocking or interruptions. And then this is a topology implementation that I use for this paper. There is 3 switch, 4 PC, korban 1, korban 2, penyerang, and server, and then 1 controller in the top of the network. Okay, how is it going? First, every message in SDN architecture will be scanning by DPI. And then second, scanning process of DPI will be like this. First, getting original packet, and then flow period treatment, and then third is pattern matching, and the fourth is writing flow table. The pattern matching is very common for DPI, because when DPI scanning the messages, DPI will choose whether the message is danger or not from the pattern matching. Okay, the third is attackers will be known by DPI when doing blocking. Okay, after 10 times running script attack and checking the performance, average of delay and bandwidth like this. Delay, before the attack comes, delay was 0.16 millisecond, and after attack is 0.185 millisecond. And for bandwidth, before the attack is 8.26 Mbps, and after is 7.89 Mbps. From the delay, we can see that there is some increasement, but it's not so significant. And for bandwidth, there is decreasement and not significant too, because it's just decreasing and increasing about 0.1. Okay. So the conclusion for this paper is, according to the analysis that has been done for the scanner attack, the results show that delay and bandwidth after attack once is not significant, make this too bad. Also, the packet inspection can possibly detect the attack, so it's good for the software-defined network architecture to maintain the attackers. Maybe that's all that I have to do presenting. Sorry for my bad language. Thank you.